So how you guys doing? You alright? That's a rough question to answer. You're like, I'm still here, buddy. So it's getting close to the end, man. Alright. So how are we doing with this stuff? Any questions from home? Yeah.
Do we have something like 4x plus 12, 6x plus 18? Are you just supposed to factor in simplify?
Totally. So do it again.
4x plus 12 over 6x plus 18.
So we got to be careful because we're not used to seeing something that looks like this. We're not used to it. We're used to seeing that. We're used to that's fine, but we're not used to seeing expressions inside rational, inside something, right? We're not used to seeing rational expressions. We're not used to seeing polynomials over other polynomials. It's different. So our brain sort of sees 4 over 6 and says, I know what to do with 4 over 6. And then you go, that's nice, brain. Calm yourself down. Because the bigger idea is, can I reduce this? No, even if I write 11 as 10 plus 1, just because I wrote 11 in a different way doesn't change it. It's still 11. So but can I reduce this? Yes, I can, totally. And what we do without showing ourselves, we divide by 5, right? 5 goes into both. But what you're really saying to yourself then is 10 has a 5 in it, and so does 15. I really want this to make sense because our immediate hope is not what's real. We can't just start attacking things immediately because division can only cancel multiplication. You can't cancel addition or subtraction. So here, this is all multiplication. That's why those go away. Here, I can't make those go away because division cannot touch a part of an addition problem. I like it. Now, just to make sure you really understand, because somebody might bring up something we've done before, if I have, what you got, Jeff? I don't know, Jeff. So if I had 11 over, let's say 11 over 10. So I can't reduce this, right? But I could say this is, again, if I do this, I still can't kill the 10s, can I? I cannot do that. It's not allowed. But I can totally all day write this like this. And then what do I have? I have that fraction, which I can do something with. And I have that fraction, which just sits there, right? So there's a difference between somebody who wants to do this is wrong, because what do you think they would think the answer is? Either 1 or 2. 1, you can see where they get that. Wherever they get 2 from, well, 10 divided by 10 is 1, plus 1 is 2. No. So not. So not. This is not breaking what I'm saying, though. I've broken it up so that this is division only, this is division only. That's why I'm allowed to reduce both of those. I like it. Yes, sir?
You're doing because it'd be 1 over 0.
Here? Well, it would be like there's a 1 still down there. Right? When you cancel those. Okay. Well, let's take that away because that's poor. That's no good. Don't do that. So here I can't even do that thing I just did. I can't break it up because the bottom has 2 terms. Remember we talked about that? So the only thing I can hope to do is something like we did here, which is to factor. And we do that without even realizing that that's really what we're doing. You don't even think of it that way. And I don't blame you for not thinking about it that way. And some of you guys are probably like, why the hell would I do that shit? But this is so you realize that's what I have to do here. So how do you factor the top?
GCF.
Beautiful.
4.
Good.
X minus 3.
Alright. So somebody else. How do you factor the bottom?
6.
Good.
X goes to 2, 3.
3. I like it.
Cancel.
Yeah, good. Now, those die. And
12 over 3.
that becomes
2 over
2 over 3.
so you get 2/3. Because you let the bar do its work. What's this bar mean? Divide. So if I give it a bunch of multiplication stuff, it can do its job. It can do something. Here, it can't do shit. It's like, what do you want me to do? Why did I get out of bed? For a little division bar. Maybe. Even though I just said all this, I'm still going to have people that just start to cancel stuff out. And I almost can't blame you, except I will. I'm trying to get you to understand you can't cancel addition problems with division. You can't. You can't even break this sucker up like we did a second ago. You can't. Okay. Anything else? Yes?
Some questions in 104 and 71.
Oh, 7-1, number 104.
Yeah.
Okay. Oh, yeah, that's a neat question. It was
6 also. All
number
the-
104, right? The one about the
One of
die? The one about the rolling dice?
Uh-huh.
Okay. Let me ask you this. If I flip a coin, what's the probability that I get a head?
2.
1 out of 2. I love it. Why is it 1 out of 2? Because it's how many
2
sides?
faces.
2 sides. And how many do I want to find? 1. I wanted the probability I get a head. So I get a 1 out of 2 chance. That's amazing. Well, if I have a die that I'm rolling, normal die, don't bring in Dungeons and Dragons, don't bring in 20-sided die, no, just a 6-sided die.
1 out of 6.
1 out of 6 for any individual side. But what if I said I want the probability to get a 2 or a 3? Now there are 2 things that match what I'm looking for out of 6 sides, so it's 2 out of 6. I like it. So like if you buy 2 lottery tickets, you doubled your chances to win. From 0.0003 to 0.006% chance to win. Yay! Alright. Is that cool?
Yeah.
So that one, number 104, seems like it comes out of nowhere, but it's just, probability is all about making ratios of chances. Right? That's what probability is. And which one? Number 6?
7
7.
and 8.
In that same section?
Yes.
So, anytime we learn a new way to combine algebraic stuff, one thing we want to do is remind ourselves that we can just plug in numbers for the variables. That's what variables are there for. It's just to be anything I want them to be. Almost anything. So, number 7 says 3 over x, and it gives me a value of x. What value of x can it not give me?
3.
0. Couldn't be 0, right? If they said 0, I'd just say undefined. I'd be like, I can't do that shit. Leave me alone. But they tell me evaluate this for 7. Negative 7? Cool. I like it. So then, what do you do? What's x?
You just
Sorry.
plug X.
Sorry, not 7. 107.
Oh, 107. All right, so this will be 3 over negative 7. That's not a big deal.
This one.
That freaked me out because you're like one side and then the other. Oh, all right.
107 and 108.
I'll talk about 107, and then it's the same kind of idea for 108.
Okay.
Let's see. Somebody remind me, if I give you distance, rate, and time, what is the equation that relates those things?
Rate equal time.
Dirt.
over-
Yeah. Distance is rate times time. If I'm going 40 miles an hour for 2 hours, I'm going to end up going 80 miles. We know that. It's just the math we don't automatically know, because the math wants to make it general. Formulas are always more difficult looking than the actual work that I would do. So 107 says, you know that we're going 60 miles an hour. So which variable is that?
No,
Right.
T.
R.
Sorry.
What's D? Distance. Miles per hour, not a distance. What's T?
Time.
Miles per hour, not a time. Process of elimination, it's got to be the rate. Miles per hour, that's a rate. Something per something, that's a rate. So R is 60 miles an hour. What's it tell me here? Blah, blah. How long does it take the car to travel 360 miles? So part A says, how long? So what is it that I don't know?
Time.
Time. How long does it take to go 360 miles? And what's 360?
6 hours. Distance.
Distance. So it's just plug and chug. Again, it's kind of a weird question, but I just wanted to keep you guys remembering that distance equals rate times time. This is just plug and chug, really. Plug and chug. Plug a 360 in for D. You know, R is 60. You can solve for time then, right? Solve for time. If you're ever on a long road trip, I'm hoping to God you know how to do this kind of thing. Are we going to make it there by 8? We got 300 miles to go. Well, I'm averaging about 50 miles. You should be able to kind of figure out, am I going to make it there on time? You have to. Or is there an app nowadays? Siri, tell me. Oh, screw it. Humans are just going to go the wayside. We are out. Robots will take over. The world will be ruled by iPhones. It's a weird ass science fiction movie. Anything else from homework? Anybody else doing homework? You guys doing homework?
36, the same section. When I 36.
Oh yeah, okay.
2x minus 1 can't.
When I ask you what makes a fraction undefined, what's the only thing I care about? What can't happen? Bottom can't be 0. So do I care what the top is? No. So that's number one to realize. So this whole section of the homework where 36 sits says find any values that make this expression undefined.
Okay.
Good. So it gives you this.
Minus 7x plus 10.
So listen up, because this is going to happen to you in the next level of math. You're going to do a little more complicated functions, a little more complicated expressions, but they're going to ask you the same question. So for example, I know we haven't made it there. I can't remember if I said this already. What can you not put inside a square root and have it come out real? What can you not take the square root of? I can take the square root of 0 all day long. Square root of 1 is 1. What kind of number can I not put in there? So what is the square? I know we haven't talked about this officially, but real quick.
2.
Square root of 4 is?
2.
2. Square root of 9 is?
3.
3. Square root of 7? I don't know, but it's still fine, right? It's not undefined, it's just some ugly number. What times itself is 7? There is such a number. There's a number that does that. Right? We know the nice ones. What kind of number can I not?
Not compose prime.
What's the square root of negative 4? No, what's negative 2 times negative 2?
2.
Yeah, that's why you have to have imaginary.
Imaginary, I love it. What's the square root mean? Something times itself equals the inside. I cannot have a real number times itself equal this, can I? Because then the signs would be the same, wouldn't they? Negative 2 times negative 2, positive. Oh shit, 2 times, oh, that's silly. That's not. So I can't have negatives in there. So if they ask you what makes this undefined, you would say x less than 0 would make it undefined. So in English, you would say to yourself, the inside, when it's less than 0, makes it. So the inside, another way to say this is the inside has to be at least 0. So that would make it undefined. This is what it has to be. So what I'm trying to tell you is, how do I say this in English? And then you already told me, what can't happen in a fraction? The bottom can't be 0. Now, translate that English, and that is English, believe it or not, into math. The bottom, what's the bottom? Beautiful, I love it. What is it?
X minus
X squared minus 7x plus 10 can't be
0.
And now how do you solve that? So as you can say it in English, what makes this function freak out? Or what does this function have to have happen? This has to happen. It can't. The bottom can't be 0. I say that in English, I write it in Mathish, and then I solve it. How do I solve this?
X.
Good, right? I don't subtract 10. I don't do that. What tells me I have to do what you're saying?
Yeah. 5.
Square.
X. Yeah.
So I have to factor this. So x.
Minus 2 minus 5.
Minus 2 minus 5. So x can't be
2.
2.
And x can't be 5.
Yes. So you focus on the bottom. Did this come into play at all?
Not even close.
Good. Because I don't care where the top is. The bottom can't be 0. The top can be any damn thing it wants to be. So when they ask you what makes this undefined, you basically set the bottom not equal to 0. Or equal to 0. I mean, that's technically right. So you're finding the values that make it not work. I just like to really make it in your face that it can't be 0. It can't be. That's the good way to look at it. Okay. How are we doing? Anything else from homework? No. Okay. All right. So let's do this. I want to do a little bit of the next idea. And actually, before I do that, let's do this. Sure. Yes, sir.
How come the x is not equal -2 and the x is not equal -4?
Oh yeah, well, right here, what can I write? I can say either this is not 0, or this,
Subtraction.
and then you add
Add
2.
2 to what's x?
If x were -2, this would be -4, that's fine. I just don't want this to be 0. So what do I subtract 2 from to make it 0? 2. So you can always say this factor related to 0, or the other factor related to 0. Solve each, right? But I'm hoping some of you guys are starting to realize, especially when it's, if I solve this, what are my answers?
X can be negative
-11?
and can be
4.
4.
Because if I did say x plus 11 equals 0, or x minus 4 equals 0, they would change signs when I brought them to the other
By the
side.
time you did the algebra.
Exactly, I like it. So I don't mean to skip steps and make you get lost. This is the step that you do. You set each piece equal to 0. But when it's simple like this, you can kind of see it's just going to be the opposite of the number that's in there. -11 plus 11 will be 0. I want to get you to that point. Okay. So if I want to simplify this, what would I do? Thank God we've gotten past long division, right?
Yes.
That is an option for some problems, but not this one. If I want to simplify this, I'm going to try to reduce it. So yeah, so good, GCF. What comes out of the top?
X.
X.
X squared.
X cubed.
Minus 8.
Alright. What comes out of the bottom?
X.
Oh.
X squared plus 2. 2x plus 4.
I like it. So what can I already kill?
X.
You guys cool with that? Let me get rid of that. Just get rid of it. Don't like it. Yes, sir.
Because it's not a number, you can do that.
Well, I mean, even if it was a number, I mean, if I had 5x over 5y, wouldn't the 5s go away? Right? I mean, so whatever's the same on the top and the bottom, whatever it is, I can cancel it out.
It's not between them multiplication.
As long as it's multiplication. Yeah, exactly.
Never mind.
Cool. I like it.
Because of the parentheses.
Exactly, because this means x times stuff. X times stuff, so division can kill that piece. Now, can I kill anything else in here? No, because they're separated by subtraction and shit. So what do I have to do?
Big dude factor.
I like it. This guy is a little dude, big dude. Anytime, let me see if you guys get this. Anytime you have a cube in one of these problems, some 3-term dude could be his big dude. There's a lot of dudes in the statement I just made. So when I break this up, what's true about this piece? Always, unless there's a GCFE left in there, you can never factor this. So if you try to factor this, you're going to go a little insane, because I constructed it so that that's the big dude. The whole damn thing's going to cancel. So when you have a cube and there's a trinomial that you like that won't factor, maybe it's the big dude. Maybe the whole damn thing goes away. So you can't always factor parts of this. Maybe whole parts of it are going to cancel. So what do I get on the top here? I get x, 2, 2,
X minus 2.
x minus 2, I like it. X squared.
Plus 2x.
Good. Plus
2x.
2x
And plus 4.
plus 4. So sure enough, what are both the top and the bottom half? X squared plus 2x plus 4. That whole thing can go in. Because whatever number this is, it's on the top and the bottom. So it can cancel.
Even if we are able to factor that bottom, the x squared plus 2x plus 4, we are able to factor it.
If you were able to, then it wouldn't be a part of this. Because you can never factor the big dude. But maybe I would give you a bottom that could factor and maybe would cancel with this guy. Maybe. What I'm saying is, if there's a trinomial that you can't factor, you're like, this won't factor, maybe it's the big dude that will, the whole thing will cancel at once. But, sing it. Start with the cubes. Always do the cubes first. And then you're like, oh shit, I'm not going to waste any time because I can see right there the whole thing cancels. Yeah. Start with the cubes first if there is a cube in there. Now, if the problem would have been, so this is getting to the question I just had. Same top, different bottom. If the problem would have been this, screw it, let's just get to the point. Can I start canceling stuff?
No.
Hell no, why not?
Subtraction.
Subtraction, oh shit. Division cannot break into a subtraction problem. It can't, it's not its job. It's not what it does. It kills parts of a multiplication problem. That's why the whole thing here is factor. That's why in chapter 6 I said, you better get factoring down now because all of chapter 7 is factor. You can't factor, you can't do chapter 7, period. So the top we already factored, right? It's right there. How do you factor the bottom?
Square, x plus square,
X minus 2.
X plus 2.
And what cancels?
X minus 2.
That's right. Cool. And I don't waste time on this because it's the big dude. It can only factor if there's a GCF I left. Only GCF. It can never ever factor like this. Ever. The big dude can never factor like that. Don't waste time. That's it. That's the answer right there. Okay, maybe. So the more capable you are of factoring, the easier chapter 7 is going to be. Easier. I didn't say easy, just easier. All right. Okay. So here's the next kind of level to this. And this is not a huge step. So recall, let me give you an easy first problem, then a slightly harder second problem, then we'll see how it translates into now. If you had this, what you got, Jeff? I don't know. What would you do to reduce that?
Divided with 7.
Yeah, this is 7 times 7, this is 7 times
10. No, 7 times 20.
2, honey.
Oh,
7's go in. That's amazing. Ooh, that's amazing. So, what if I had this? That's neat, Jeff. Doesn't matter. Let's see. You can do it. There's all kinds of stuff I can do here. Whatever you see first. As long as one of them's on the top, one of them's on the bottom, because that means division. It's going to cancel, right? You can't cancel across. So, like between these two, for example.
7.
Yeah. So you're left with a 2 when you divide by 7 and a 10.
That's fine. That's 5.
Right? And then you can go one more.
yes,
So
2.
that'd be 1,
5.
5. All right, let me stop there for a second. Is that cool? We all remember you can go diagonal, you can go up and down. Like right here.
Yeah. Or
that way, sure, but right here, what do we got?
7.
1, 7. Can these reduce?
No.
No, so what do I get? 1 times 7?
7
over
7? 25 times 1?
25.
25, I like it. I'm going to let you absorb that. That's old news. That is very old news. But do you remember it? I mean, as long as something's on the top and the same thing's on the bottom, I can kill them. Yes, sir.
How did you get rid of that 5?
Oh, all right. So in the process of doing this, so right here we got 2 and 10 here, and then divide by 2, divide by 2. And then right here, 5, divide by 5, divide by 5.
I think normally you would just do that way.
No, yeah. So the reason I forced it to go this way is just remind you, you can do diagonally or you can do straight up and down. Of course you can.
So if you would have gone the other way, like it would have given you.
So you did 2
5.
separate processes over each other.
Yeah.
So the idea is, as long as one of the numbers is on the bottom and the same numbers on the top, wherever they are, they can die.
So wouldn't you get a different answer if you
No, totally, you can't.
25 and then 35.
All right, let's see. 11. So 25. What can they both be divided by? 5.
Seven.
Now where do you want to go? What about here?
1 plus
1 over 10.
Now what about here?
2.
So 7 over
7.
Five.
5.
Okay.
7 times 1 is 7. 5 times 5 is
25.
25. I really want you, just because you rearranged the way you work with the parts, you didn't change what the parts were. You just did them in a different order. So of course the answer is going to come out the same. This times this is a single number. Just because you look at it differently doesn't change the number. I wish, then my checkbook, maybe you're like, well, that's negative. If I do this, it's positive. No, shit. If I rearrange the negatives and positives, it's going to come out negative. Oh, shit. You guys kind of get that? So it's the same process I'm applying. I'm just doing it in a different order sometimes.
So it's okay to go diagonal and up and down, just not side to side.
Exactly. You multiply side to side. You cancel up and down. I like it. And that's why we got 7 times 1, 5 times 5. Cross, you multiply. I like it. How we doing so far? Is that decent?
How'd you get the 5 down to the 10? There, yeah.
Here. All right. So again, when you look at the end result, it's hard to go back to what you did. So it depends. For yourself, if you want to write multiple steps and do one thing at a time, you can totally do that. Me, I wouldn't want to do it that way. But, all right, let's see.
It's going diagonally.
First thing we did was, what was the first thing we did?
25, 35.
40.
25, 55.
Oh yeah, we did this first. So we got the 5 and the 7.
Yeah?
Then we did this.
Correct.
So we got the 1 and the 10. Then we did this.
Yeah, yeah.
And we got the 7 and the 5. So as I'm doing it, you need to watch. Yeah. And for yourselves, though, I mean, again, this is old news. That's why I'm going a little bit quickly through this. This is really old news. But I want to dredge it back up. We should be able to reduce this relatively easily. You should be like, please, Jeff, give me a lot of these. Should be the way you feel about it. So how does it relate to this weird stuff we're doing now? I don't know.
This is 7.2, right?
7.2, yeah.
Multiplication between.
So that all that's going to happen is the problems are going to get a little bigger, right? Because now there's going to be 2 rational expressions, 2 fractions next to each other. So you have something like this. Oh, what you got, Jeff? I don't know, man.
This is B or
Yummy.
is it 3B?
Say again?
36.
That's 36, right?
36, yes. I don't know what number I'm for. So again, this is section 7.2. So you first look at this as 4, possibly 4 factoring problems. It turns out it's only 3 factoring problems because this dude can't do shit with it, right? So he just sits there waiting. I have 3 factoring problems. So if you have any trouble keeping track, what you could do is you could say, all right, here's one factoring problem, here's a second one, here's a third one, and then you can attack them separately. Some of us have trouble keeping track of what the hell we're doing. So if I look at this as the one problem is this. How do I factor this? Good?
A
A
squared minus B squared.
Good. And what can I do this?
A minus B.
Good.
By
This is difference of squares, kick-ass. A minus B,
A plus B.
A plus B. So that I can put there. You guys follow? Now if you don't want to do that, you can just do it, you can just kind of equals and then just start attacking each piece all at once, right, if you want to. Or you can tear them into parts as long as you put them back in the right place. Alright. What about the second one here? How can I factor this guy? Good.
A
minus 6.
A plus 1.
Or
I like it. 6 is evil, because 2 and 3 makes 5. Right? This is kind of like evil. It looks really easy, but 2 and 3 makes 5, but they would have to be different signs, so they could never make 5. 2 and negative 3, 3 and negative 2, no. So it's got to be 6 and 1. Oh, shit. So what about the last little dude? What is this? Up here.
different square.
Yeah, number 3 is a squared minus 36. Man, little purple dude.
A plus 6, A plus
Yeah, a plus 6, a minus 6. So I've got this, and this. Alright. Now I just got to put them back in and start killing things, right? Game of fractions. No Game of Thrones fans, sorry. So let's see, we got number 1 becomes this, so I'm going to rewrite this whole thing. So on top here is this. Oh, I didn't think I had to. Oh, well, too bad for me. On the bottom here is the second dude, right? This guy.
Yeah.
On the top here is this guy here. And on the bottom is this dude that's just been sitting there waiting for a while.